In this video, we're going to solve an integral calculus problem using trigonometric substitution. So the problem is the integral of dx all over x squared minus 9. So we can see that the problem is written in this form: u squared minus a squared or x squared minus 9. So u here is equal to x and a is equal to 3. So if we see u squared minus a squared, we can make a substitution. U is equal to a secant theta. Then we're going to substitute u, that would be x. Then let's going to substitute a, which is 3, then secant theta. So this will serve as our first equation. Then we're going to derive this one. That would be dx is equal to 3. If we derive secant theta, that would be equal to secant theta tan theta d theta. So this will serve as our second equation. Then we're going to form a right triangle here. But let me rewrite this as secant theta is equal to x all over 3. We know that secant theta is equal to hypotenuse all over adjacent. So hypotenuse, the x will be going here, then 3 will be going here. So meaning that the opposite side will be equal to x squared minus 9, the square root of it. Then from there, we need to get the value of tan theta. So we know that tan theta is equal to the opposite over adjacent. So our opposite here is equal to the square root of x squared minus 9 all over our adjacent, which is 3. Then we're going to multiply both sides by 3. So that would be equal to 3 tan theta is equal to the square root of x squared minus 9. So this will serve as our third equation. Oh, let me just square it. So this would be equal to 9 tan squared theta is equal to x squared minus 9. So this will serve as our third equation. So let me just rewrite the original problem, which is the integral of dx all over x squared minus 9. We know that dx is equal to 3 secant theta tan theta d theta. And x squared minus 9 is equal to 9 tan squared theta. Then we can cancel 1 tan here, and let me just rewrite the problem. So 3 over 9, that is equal to 1/3 the integral of secant theta tan theta d theta. So we know that secant theta is equal to 1 all over cosine theta, and tan theta is equal to sine theta all over cosine theta. Then we can cancel cosine theta and cosine theta there, and we'll be left with 1/3 the integral of 1 all over sine theta d theta. Oh, I forgot the d theta here. But we know that 1 over sine is equal to cosecant theta d theta. So let's now integrate cosecant theta d theta. That would be equal to negative ln cosecant theta plus cotangent theta plus c. But we need to rewrite cosecant theta and cotangent theta in terms of x. So let's do that. So let me just copy our triangle here. So cosecant theta, we know that cosecant theta is equal to hypotenuse all over opposite. So this would be equal to x all over the square root of x squared minus 9. Then let's rewrite cotangent theta. We know that cotangent theta is equal to the adjacent all over opposite. So our adjacent here is 3. Then opposite is the square root of x squared minus 9. So let's now rewrite our answer here. So negative 1/3 ln cosecant theta is equal to x all over the square root of x squared minus 9 plus 3 the square root of x squared minus 9 plus c. But we can combine these two here since they have the same denominator. So let me just erase this one because I don't have any space left. And let me just simplify our final answer as negative 1/3 ln. Then let's combine the two. So this would be equal to x plus 3 all over the square root of x squared minus 9 plus c. So that's the answer to the problem. I hope you guys learned something today. See you again next time.